Hello everyone and welcome back to Simply Biology. Today we're going to be looking at carbohydrates. Now, just important to mention that carbohydrates, along with proteins, lipids and nucleic acids, are the four main types of carbon compound that make up living cells. Now, carbohydrates can be split into monosaccharides, which are simple sugars, disaccharides and polysaccharides. So, without further ado, let's get started. And we're going to start with the rules of carbohydrates. So, carbohydrates provide an energy source, e.g. glucose for respiration. So when your body requires energy, the glucose is broken down and it is used through respiration in order to produce energy for the muscles to respire. Then it also uses an energy store, for example glycogen in the liver. So insulin converts glucose in the blood to glycogen in order to be stored in the liver. Just a quick note, glycogen is known as a polysaccharide. And finally, they're used as cell markers and for cell identification through processes of the glycolax and glycoproteins, where carbohydrates are joined to lipids to form glycolipids and proteins to form glycoproteins, and these enable the cell to adhere and cohesive and adhesive properties, and also to identify the cell. We'll move on to simple sugars, which are referred to as monosaccharides. So here you can see I've drawn an image or the displayed formula of two monosaccharides. On the left here is galactose, on the right is beta-glucose. And the difference between them, they're known as structural isomers because they have the same molecular formula but a different structural formula. Because here, if you look at carbon number 1, the OH, the hydroxyl group, is it switch places. At beta-glucose, the hydroxyl group is below on carbon number 1, and whereas galactose, it's above. And you can see you've got the hydroxyl group is above on carbon number 1, and it's also above on carbon number 4. Then, in beta-glucose, it's below on carbon number 1 and above on carbon number 4. So there's subtle differences, but these give the individual monosaccharides their chemical properties and therefore they differ from each other very slightly. Now we shall have the simple sugars, in joining two monosaccharides together creates what's known as a disaccharide, and there's a few here to have a look at. So alpha glucose, this sign means alpha. Alpha glucose plus alpha glucose gives you maltose. Alpha glucose and galactose produces lactose. And then alpha glucose and fructose gives you sucrose. And it's important to note that all these disaccharides, maltose, lactose and sucrose, are all produced by condensation reactions. And we'll have a look at the mechanism now. So as I've just mentioned, two monosaccharides are joined together by a process of condensation reaction, which involves the formation of the disaccharide molecule and the elimination of a smaller molecule such as water, H2O. So here we have galactose, and here we have alpha glucose. And this reacts together in a condensation reaction to produce this molecule here, and if you remember from the previous equations, this molecule is lactose. Now it is important to note that this bond that joins these two monosaccharides together to form the disaccharide is known as a 1,4 glycosidic bond. It's between carbon number 1 on this molecule and carbon number 4 on this molecule. Now, in order to split this disaccharide apart into its constitutional monosaccharides, the hydrolysis is used, hydrolysis is the addition of water to separate the disaccharides into the monosaccharides. So in order to reverse this change, you use a hydrolysis reaction. So condensation forms the disaccharide, a hydrolysis separates the disaccharide back into the two monomers. Now finally, we're going to look at the longest type of carbohydrate, and this is known as a polysaccharide. You may have heard this before. So these contain multiple monosaccharides bonded together. So the monosaccharides are known as the monomers, and the polysaccharide is the long repeating polymer. There are two types of polysaccharide that we need to know. They're known as amylose and amylopectin. So amylose is a straight chain molecule, and it therefore only has 1,4-glycosidic bonds. Remember, it is insoluble and it is not easily digested and consists of about 30% starch. Amylopectin, on the other hand, is a highly branched molecule, so it also contains 1,4-glycosidic bonds, but due to the branches, it also contains 1,6-glycosidic bonds. Amylopectin is soluble and it's more easily digestible, and is also about 70% starch. It's also important to note that both amylose and amylopectin are made from alpha glucose. Thank you very much for watching this video, and I hope you now understand more about carbohydrates. Thank you. Goodbye.